These are the types of problems that I would not put on a test. But I would put in front of a group of us, especially when you have the opportunity to work together, because it involves a lot of different kinds of thinking, right? How did you approach this task? Even if you didn't come up with an answer, sort of how did you begin the problem-solving process here? So one of the first things, and we sort of did this step together, is we took some of the words that were being used to describe the problem here, and we just translated them into a mathematical statement, right? If 2 plus a fraction produces a number that's twice as big, that means that 2 plus that fraction has to equal 4. And then what you said was that we can rearrange this by subtracting this 2 from both sides to discover that what that's really asking us to do is to find a fraction whose value is 4 minus 2, namely 2. Right? So it tells us that the fraction which works to meet this first requirement needs to be a fraction whose value as a rational number is equal to 2. Did you also do that for this number sentence down here at the bottom? For my multiplication sentence down here, what I want is I want this fraction to come out to be 1/2. Okay? Another way to see that is by using the same trick we used up here. Up here we subtracted 2 from both sides. Down here, what should I do to move this 2? Divide by 2 on both sides. So if I divide by 2 over here and I divide by 2 over here, then I find out that my fraction needs to equal 1/2 for this next bit. So that gives me, again, a little bit more concrete information about how to do the addition task and how to do the multiplication task. And we talked about how the subtraction task will always be satisfied, right? It will always give me a smaller number when I subtract 2 minus something which uses the digits 2 through 9 as a fraction, right? So let's not worry about this one. Let's worry about these two. So give me an example of a fraction, numerator over denominator, which equals 2. 8 over 4. Sure, let's try it. So if I put an 8 over 4 here. Sorry, wrong boxes. 8 over 4 does come out to be 2. So let's suppose we try the 8 over 4 there. Give me another example of a fraction here. 3 over 6? Sure, that comes out to be 1/2. And again, the rules here are that we were to use the digits 2 through 9 and use none of them more than once. And so far, we're okay with that, right? 8 over 4 in the first example, 3 over 6 in the second example. All right, that does it for those two. So now let's go to our last one. If I divide 2 divided by something and the result is larger, what does that tell me about these two numbers? Usually when we divide, when we think in English about dividing, usually the mental picture is that when you divide, you make things smaller. So how can I divide and make the result bigger? What does this fraction have to be? Interesting. So the fraction should be a proper fraction. The reason being that how do I rewrite a division problem as a multiplication problem? If I want to divide by a fraction, what is that the same thing as doing?
Multiplying by the reverse.
Yeah, it's the same thing as multiplying by the reciprocal, right? And so if I want the product to be larger than 2, that means that this fraction here needs to be larger than 1. This fraction is going to be larger than 1 if that fraction is smaller than 1. So what we need here is we need a fraction which is smaller than 1. And if it's smaller than 1, what does that tell me about its numerator and its denominator? If this fraction is smaller than 1, what relationship do the numerator and denominator have? Which one's bigger? The denominator. So I need to have a smaller number up here and a larger number down there. Well, we have a lot of options, right? What should we try? From 2 through 9. What do you want to do?
5 over 9.
Okay, we haven't used 5 or 9 yet, so let's just put it in there. 5 over 9. 2 divided by 5/9 does, in fact, produce a larger number, namely 18 over 5, which is 3.6. Okay, great. So now we have all three of these satisfied, and what digits are left over? What haven't we used yet? We haven't used 2, and we haven't used 7, if I'm getting this right. So now how do I fill in my last number sentence up here? really any old way I want, because that difference is always going to be smaller than 2. So now we can look through and find out that this is one solution to this puzzle. Right? 2 plus 8 over 4 gives me a number that's twice as big as 2. 2 minus 2/7 produces a number that's smaller than 2. 2 times 3 over 6 produces a number that's half as big as 2. And then 2 divided by 5/9 produces a number that's larger than 2. So there's one possible solution. The kind of questions that math majors love are there other solutions? Is this the only way to do this? Or could we have done it a different way? I feel like we made some choices that maybe we could have made differently. Right? Some choices we were stuck with. Right? This had to divide out to be 2. This had to divide out to be a half. But we could have maybe tried 4 over 8 down here and 6 over 3 up there. Gives me a different solution. So, there are a lot of math problems, and particularly these problem-solving type ones, that there may be multiple solutions in addition to multiple ways to get to the solution.